JuliaHub webinar using large data sets in JuliaHub. I'm Jay Jagdish, a part of the marketing team here at JuliaHub. Today, Dr. Matt Bauman will walk us through using large data sets in the JuliaHub platform. A little background on Dr. Bauman. He is the Director of Sales Engineering here at JuliaHub, helping introduce and onboard customers to the company's products. He holds his PhD from the University of Pittsburgh and has been working with Julia to analyze data sets ranging from gigabytes to terabytes for the last 9 years. If you have any questions during this webinar, please enter them into the chat and we will answer them at the end of the session. It's time to get excited. Over to you, Matt.
Great. Thank you so much. And welcome, everyone. I'm excited to talk to you today about how you can use JuliaHub to work with large data sets. What large means is a little bit nebulous and kind of intentionally so. But this will give you a taste of how you can work with data that is otherwise cumbersome to work with, and how JuliaHub can help structure and orient your data in a way that is easier to work through. So just to kind of give you a lay of the land of where we'll go today, I'll just kind of do a very brief bit of slides on what JuliaHub is, kind of an overview of where it's going and specifically its data capabilities. Most of the time, though, I really want to be spending in live demos, showing you how JuliaHub works to import and upload your data into the system, and then work with it to do fun parallel computations. The key components here are really going to be about the data themselves, to get them uploaded and working with them. The actual computations I'm doing aren't going to be the most interesting, but they should be extraordinarily helpful in kind of getting your head around how you work with the data in general. And then lastly, we'll end with a bit of a recap and handle Q&A questions at that point. So JuliaHub, just to kind of level set here, if you're not familiar with it, I encourage you to check it out at juliahub.com. It is our enterprise computing platform that is really the easiest way to get Julia running on the cloud. We know Julia, and we have optimized this platform for Julia and running it. And there are kind of 4 tent poles to the platform. The first is being able to develop your code, doing so either in a notebook interface or in VS Code in an integrated development environment. You can do that to build out packages and other tools that are common to your team or the open source infrastructure in general. And then you can take that and scale that code, both vertically and horizontally, with bigger machines than you have at your desktop, and more machines than are possible to run it in your desktop, using AWS as our backend. And then the part that I'm going to be talking about most today is being able to work with large data sets and doing so in parallel. So just to kind of do a quick screen through these tentpole features, we have what are called applications on JuliaHub that allow you to launch the editor and such. And then you can go in and use APIs as well to manipulate the cluster and do things more programmatically. We'll see a taste of both of these in this session today. The integrated environment is what you expect. VS Code, like you work with locally, one of the best environments for working with Julia code, is supported directly on the cloud. And within JuliaHub, you don't need to install anything locally. It's all right there. Single click gets you up and running. And of course, has all the great integrations with version control, the debugger, a place to work with your code. This is the interactive drive that I'll talk about, and as one place that you can store data on JuliaHub. And then, of course, integrated documentation and editing right there. Once you have some code that you want to work with, you can scale it out. And when I talk about both vertical and horizontal scale, I mean vertically as in bigger machines, right? So you can even choose GPU machines that have that, or more cores than are available to you locally, or more memory than is available to you locally. And then out by combining them together using Julia's built-in distributed standard library to connect them, automatically having them all connected for you. And you can run code across thousands of cores very easily this way. We have cost controls built into the platform, and you just click Start Job, and it'll find whatever file you're working with, bundle it up with all of its dependencies in that folder, and submit it into the cluster for a reproducible sort of system for running it. And then, of course, once you have some data, you can use any of Julia's great plotting tools to visualize them directly within the platform. Where I want to spend my time, though, today is talking about data, and specifically data on JuliaHub. And so within the Visual Studio Code environment, there are two places where you can work with data. There's the interactive drive. That is kind of your working directories where you can edit and play with code with version control and all sorts of fun things that you can do as you would expect. And this is a persistent directory that is shared across all the applications that we have on JuliaHub. And so you can go in, edit things. You can import data sets directly here, but it's a little limited in the size and rigor that you can use there. And so that's where proper data sets, as we call them, in JuliaHub can be extraordinarily helpful. And this is a structured way of referring to your data that can be larger than what can fit on a single disk, for example. Or larger than what can fit on a drive. And so this allows a nice rigorous way of looking at your data. And that's also visible within VS Code, but through a different interface here. So in this screenshot here, we're looking at the JuliaHub plugin tab that has access to all of the data sets that are available on JuliaHub. So that's kind of the lay of the land. I really want to just spend most of my time looking at what the system looks like. And let's start with small data, right? So let's grab some sort of interesting data set that we want to look at. And to do that, let's pull in some data from New York City's open data portal. Their Taxi and Limousine Commission has lots of really fun data that you can look at in the form of trip records from all the taxis that are run in New York City. And these are separated out into lots of per month files. They're all Parquet files here. And so you can grab a single record, for example. We can go in just the most recent trip records from the yellow taxi cab. You click it, it'll download locally to my laptop here, and then I could load it. So how do I get that data into JuliaHub? Well, I've already gone through and downloaded all of these data sets here. I have them all available to me in a folder here that all told is 50 gigabytes worth of data. This is kind of on the edge of what I would think of as large data. Definitely not big data, right? but it's big enough that it can give you a taste of what things look like here. And so all of these files are here, ranging from a few megabytes to half a gig or so, depending upon what month and what taxi cab type the data are. So let's just see how I could start working with this. And to do that on JuliaHub, we'll just go to juliahub.com. I can log in here. And let's see, continue with my single sign-on accounts. And I have already been in the system, so I've already launched a Julia editor, so I can work with it here. This is the way the system looks. So I will connect to my editor. And here we have a view into the Julia editor, the integrated development environment, right at my fingertips. I have some files that I've already been working on in my interactive drive. This is the drive that I was talking about. It's persistent across all the sessions that I work with, and it saves my work here. So I can go in and, look at a particular folder or something. I have my webinar folder all set up with a package manager, so I can activate the webinar using the package manager. And that gives me access to a handful of packages that I'm going to use throughout this demo. So how would I work with the data sets as we go through this? Well, one way to bring in data into JuliaHub is just drag and drop. I could take one of these relatively small trip data parquet files and grab it and drag it and drop it into my my folder. Oh, looks like I've already done that for this one. So it says, do I want to replace it? I could replace it, or I could grab another one, right? It could, and you can see both of those files here are uploaded into my workspace that I can work with in Julia. So I can say, all right, let's use DataFrames and the Parquet package to read these in and grab the information from them. Oh, shucks, somehow I lost my precompile state. Typically that saves, so it'll take just a moment to compile that. And we'll be able to see the Parquet files. So that is, how we can upload them here as individual files. Here we go. So data frame of the read Parquet of, say, our green trip data, 2020-07, sure. And that'll go through, read the Parquet file, convert it into a data frame, and then I can interactively work with it here, kind of explore the data. It's a nice exploratory way of seeing what's available to me. You can see in this case, it's a relatively small data frame of 72,000 rows. I can do something similar as a data set. So going back to juliahub.com, under the compute menu here, we have direct access to those data sets that I was talking about. And here I can say, hey, let's add a data set. So this will be, I can go in and grab that file, that same file that I looked at there, this green trip data. I can name it green trip data from 2022 Parquet, right? So that's my this is my file. I can give it a description, right? This is just a single month of green taxi cabs in NYC. And you can give it some tags. It remembers the tags that you've used before. And then hit upload. And this will upload that file through the browser. And again, that works really nicely for relatively small data sets, right? 1.2 megabytes. But it doesn't work well if I wanted to upload all 50 some gigabytes of my entire folder there, right? If I wanted to add many of these files, I don't want to go through individually and do that. But this is a nice option if you just have a single file. So that single file then is also accessible to me in my Visual Studio Code interface here, where I can go in and look at my data sets. And in here is this green trip data where I had uploaded, and you can see them available to me right there. So these are those single file uploads that I have. Again, it's kind of a nice way of working with just small data sets, but you don't need to work too much on you don't need too much overhead for such a small data set. You can just work with it interactively in your Explorer. So what about a bigger data set, right? If I wanted to upload all 50 gigabytes of that, how would I go about doing such a thing? I can't drag and drop it it would take forever. Plus, 50 gigabytes is going to be a pain to upload through my browser connection. It'll be slow to do so. And it's really not the most robust way of working with such a data set. So instead, let's look at just a few lines of code here that will set us up in a place where we can upload a large set of data to JuliaHub. We'll do that using the JuliaHub API. This is a package called JuliaHub Client, where we can run JuliaHub and kind of connect back in as an API. And this is a special package that is only available when you're actually running Julia on JuliaHub. It's a funny way of connecting back in with the system. And I need to authenticate into the system. And then I can, work with JuliaHub directly. This has commands to start jobs, to look at my data sets, and importantly, to upload data sets. And so I can go in and say, hey, let's upload a new data set. Let's make my screen a little bit bigger here so you can see the command that I'm using. I want to upload a data set. I name it and say what kind it is. And this is kind of a funny way of saying either I have a single file or I have a whole folder of files. And the terminology that Datasets uses for a whole folder of files is a blob tree. That is a directory of blobs. And the blobs can be anything, as the name blob could kind of is evocative of. It can be Parquet files, CSV files, all sorts of data types. It doesn't really matter what the data type is, but we need to know whether it's going to be a single file or a tree of many files. And I pass the authentication here. And so in doing this, when I say, all right, let's upload this new data set, we'll call it live upload, for example, because we're gonna do this live here. It will go in, connect to JuliaHub, and set up a new spot for this data to go. I'm not telling it what data to upload here. I'm just saying, give me the way in which I need to upload this. And it spits out a bunch of information about how to manually upload this data set. And it gives me a lot of information about AWS, credentials, and such. And this is how you can connect into the bucket in which this data will live. Normally, I would be extraordinarily horrified to display an AWS secret access key on a live webinar. That's something that you don't really want to do, but these are special credentials that are scoped specifically to this bucket that I've created. JuliaHub has just given me credentials, and they're only valid to write information into this bucket for a very short amount of time for this particular session. And as soon as I say I'm done uploading, they become invalid. So if you're very enterprising, I suppose you could go in, copy this from your screen. Good luck doing it in time, and stash some data in my bucket if you really wanted to, but please don't. But that's the point, right? That it's very scoped, and typically only I would see this thing. So how do I work with this? How do I go from a bunch of files in a data directory to upload them given this information? Well, you can use any AWS importing tool that you like to use. The one that I find extraordinarily useful and a powerful tool to use is called rclone. And it's a command line tool. It's a little bit clunky to use, but we have actually dedicated support for it right within Julia as a JLL package. So you can go to the package manager, say, let's add rclone JLL. It'll go out, fetch it, and install the binaries for you. It's a great way of doing that. I've already done that, so it didn't need to do much here. Say using rclone JLL, and this gives you access to an rclone command that says, hey, here's how we run, where that executable that Julia installed is. So I can go into Julia's shell mode now, just directly within Julia on my local laptop here, and say, let's run rclone. And without any commands, it gives me a little bit of help about how to use it. And one of the cool things about this tool, it's an open source tool, and we love interoperating with great open source any which way we can, is that it supports lots of different backends. So not only does it support uploading to S3, but you can kind of see a little bit about the backends it supports, and you can take data from any of these locations and jam it into S3 for you. So you could, for example, have a enterprise box subscription, or a Dropbox, or say Microsoft OneDrive. All of these are very easily configurable, and you can set them up and copy directly from them point to point in a nice way. So that is kind of the basics of rclone. What I want to do now is I want to create a new credentials file for S3. So I can go and do this. There's a question in the Q&A. Is rclone a Julia library? It's not. It's actually a open source tool written, I believe, in Go, but we expose it as a Julia binary. So this is through Julia's artifact systems. So it's a great open source tool, and we're just standing atop giants here where we can. So in this case, I want to add my credentials that I was granted temporarily from JuliaHub into this. And I can do that interactively just by saying rclone config, and you can set up a new remote, for example, and it'll interactively take you through a bunch of different options that you can do. I find it a little bit easier to just do this manually and say we will do create a new endpoint, or a new remote is the terminology they use, that's of type S3. You say that the provider here is AWS, and then you grab the information that you need from it. So here's my access key, just copy and paste it here, and the secret access key. Give me 1 second while I copy and paste. And the session token. And lastly, I need to say that I am in the US East 1 region, is where the default JuliaHub.com enterprise is. And this is something that actually our enterprise JuliaHub can customize, bring the data a little bit closer to you in cases. So I create this. I'm going to call it JH, just kind of as a temporary token. Gives me a bunch of things about how we did this here. And so now I can go in, and I'm in that folder that has my 50 gigabytes of data here. I can go in and say, all right, let's take my rclone, so rclone, and sync from my data folder here. And this is where you could potentially put in a reference to a different remote or something. But in this case, I just have my data folder, and output to the bucket. And so here, this is my bucket. I'm going to copy everything except for this S3, because instead of S3, I'm going to say, this is my special JH, those special credentials that I set up for this. And let's add a progress flag here so you can see what's happening as it goes. And it goes through, that's what it takes to upload this. All 45 or so gigabytes of data get uploaded pretty quickly here. And you can actually increase the parallelism to transfer more than 4 files at once. It's pretty easy to do that as well. I don't want to do that because it'll freeze up my video as I'm doing this live. rclone is very robust about this. It actually checks and makes sure that all the data is there. And so you can see we've transferred 13 of our 391 files thus far. I'm not going to wait for the whole hour that it's going to take or so to do this, but I do want to show you one more thing here, and that's if I cancel this, just interrupt it. It's synchronizing them, so it knows to restart. And if I rerun this, you can see here, it knows that there were 16 files already uploaded. So there's only 375 left to go. So it's a very robust way of doing it that is nicer than trying to do this through the web browser, for example. So this is a bit of an advanced API, but really handy when you have lots of data, scaling way beyond 50 gigabytes, right? This is a very scalable method to import data in. So I'm going to cancel this. We don't need to wait and watch this go through. And once I cancel it, I just need to hit enter to say I am all done with with this process, and that will complete the upload and make that available to me in JuliaHub. So that is precisely how I ended up with these, this complete data set here that I've already done. I call it the taxi cab data set, and the Bauman 3 in front of it, that's my user ID. And so because I've marked this as a public data set, anybody on JuliaHub.com can go and view it, can grab it. And it's an open data set. That's one of the reasons why I used it. Open data is that we're allowed to do such a thing, and you can go in and read this. And because this is all happening on the JuliaHub cluster, the data is in the same data center as the compute runs, and so it's a very efficient way of once data is in there, then I can run compute over it very quickly. So that's what it looks like to upload small data, right? I went through small data both to my interactive drive and to a data set, as well as large data. And once we have things greater than say a gigabyte or so, I encourage you to use data sets. There's a bunch of advantages to them. One is that they're versioned, that you can do this. The other is that they're referenceable from parallel tasks, because once you have a large data set, you probably want to do something interesting with it, right? You don't just want to upload data to let it sit there. You want to run some analysis over it. And if you're in JuliaHub, well, you want to use Julia to run some analysis over it. So what does that look like? So for that process, over here, I have in JuliaHub, in my session here, I have an additional file that I can run here that allows me to let me just do one thing quick here. There we go. That allows me to process my data, do some sort of processing of it. And I'll just kind of take you a quick kind of step through what this looks like and how to orient your data to process it. So I'll hide my file explorer, I'll minimize my terminal, and just kind of look at what the data looks like here in terms of running, doing a parallel processing of this. The first thing that I do is I open my data set. So you can see here that JuliaHub knows about the data sets that it has access to. And this is using the Datasets.jl Julia package to do so. That's a public open source package that we help maintain, that has special smarts about where remotes can live, and one such remote is on JuliaHub. And so I can reference this directly by name. And you can see how this gets referenced here within my JuliaHub dataset section here. So you can see I have access to all of these data sets here, both public and my own private ones. Here's this taxi cab data set down at the bottom. And I can click this use dataset button that will give me a command that I can paste in that can be used in Julia. So you can say copy this command, and we can open our Julia REPL and paste it into my session here. Hopefully, there we go. I pasted it twice. Let's see, my session is getting a little bit messy here. I am going to grab a new one, just 1 second. I've interrupted Julia too many times as I've been going through this. Okay, so we have a Julia session here. Let's again activate our webinar environment that has data sets available to us. Let's make this bigger for y'all to see. And now I can go in to my process folder here. This is looking better. We can go through and see what it looks like to process this. So let's bring in all of our functionality that we want to have, data sets, data frames, Parquet, stats-based to do some interesting statistics and dates, because all of these data sets are time-based, right? We have some time series of the taxi events. So you can see now that we have this. What happens if I just run this particular portion of it, just the reference to the data set, this connects into JuliaHub, and it gives me some metadata about it, right? It says, okay, well, this is named, it has a unique identifier. You can see the description that I've entered in, as well as the type. Remember, the type is a blob tree. That means it's a directory of many files. And here's where that storage comes in, right? It knows where this is, what bucket it lives in. It does all of the fancy AWS stuff of referencing a bucket and exposes it in a nice way to Julia that you don't need to worry about, direct access of S3 and where the data is. Doesn't really matter. The key part is, I open this, let's call it my tree of files, and that will go and grab all of these, all the lazy references to the data that are there. It kind of displays it to me as though it is a folder with kind of nice icons here. So you can see I have a tree, there's its identifier, and here are all those Parquet files, right? They're the exact same Parquet files that I had on my local drive, but now are accessible to me in my cloud computing environment. So this is kind of a fun way of working with it. In doing so, I have a representation of those 45 gigabytes worth of data, but I haven't downloaded them, right? It's very efficient and quick to work through these. I can grab a reference to a single file. So this most recent yellow data set of the yellow taxi cabs, I just index into my tree by that to grab the particular Parquet reference to a Parquet file. I still haven't actually downloaded it to my file system, but I have access to it. And then I can read this in a number of different ways. If I have a streamable way of reading it, I could just stream it as a Julia IO device, just by saying, hey, let's open this file as an IO, just kind of like you open a file if it were on your file system. In this case, I'm going to bring in some tooling that I had before to read it as a file. So I have this little helper function that I defined in this block here that reads the file system as reads the blob that I'm interested in as a file. And I can pass it some interesting commands here. So just like I did before, I can take a data frame, compose that. Let's read Parquet, and then pass in my tree of the particular data that I want here. So let's, I need a reference to my data. So those are my file names. Then I grab, oh shucks, I lost my, rewrite that. So df is my as a file. I want to data frame, read Parquet. Now I compose these like this, and then pass in my tree of the most recent data, for example. And this is a pretty big data set here that'll go out, download, those 500 gigabytes, bring it in as a data frame, and make it available to me. So this is a helpful way of working with this and kind of how you can interactively bring in these data. So you can see it loaded these, what is that, 3 million rows of data pretty quickly into my interactive session. The true power, though, is that I can do a parallel map. So I can set up a computation here. So, bring in, have my tree defined, and do a parallel map over all of my files, and do some statistics of them. So I have a very, very basic function here that given some reference to my file system here, that will do some information about it, right? Kind of bin the times at which people were picked up, give me some information about the total number of data here. And this is where you can let your data scientist's brain have fun, right? You just need to define this as a single function, how to handle one single file, and then you can map over lots of them, do kind of a parallel map reduce sort of operation to get the information that you want out of your larger data set. And here, what we do is we just pmap that stats file. I have a key here. This is forming a pair, so that way I know the TYM here is a function that I defined that just parses out the car type, the year, and the month of the data set. So that way I know where the data came from. It's just a thing that helps me in my post-processing step. So this gives me kind of the raw computation of how that works. But now I want to run this in parallel. I don't want to load all of these 45 gigabytes in my one interactive session. I want to run it across a cluster at scale. So how do I do that? Well, I go back to my JuliaHub VS Code plugin here, and I have this process.jl file that is set up as a script that can be run at scale, right? It uses pmap. It defines my functions everywhere. That means that my workers will know how to compute stats, and I use the distributed toolbox. When in the case of a JuliaHub distributed script, I don't specifically need to add processes. I don't need to connect to them. I don't need to set up their environments. It automatically does that for me by setting this up. So you can see I want to set my script as the current file that I'm working with, this process.jl. It identifies what's called the bundle directory. This is where it will find the tooling, all of the information that I need. If I were depending upon other files that were also in this, it would upload those as well, have a reference to them. And it uses the project and manifest that's in my local environment here to give me a reproducible execution of what's happening. So I will start this as a distributed job. And one of the key questions that you need to think about as you set up a distributed job is exactly how big of a cluster you want, or and how you want to configure your cluster. And that's what this kind of fancy sentence does. It tells me that I want to start I could just say, let's start a single process job that's not going to give me access to any workers. It's not going to do any distributed stuff. It's just going to run things serially. That can be nice in some cases where you want to have for example, a validated run and a stored kind of baked version of what you ran for posterity, so that way you can refer back to it. And that can be important in, for example, regulated industries where you need to know exactly the code that you ran. JuliaHub will track that and bundle it all together for you. And I'll show you what that looks like once we go in and inspect our results. But in this case, I want to do a distributed process. I want to really, the power that I want is the ability to scale out. And I'm going to set up this with a bunch of machines. So that's what the node terminology you can think of as an independent machine, and all of these machines will talk to each other. And I have a choice of, how many virtual CPUs I want on each machine. I could have them as very beefy machines, potentially even with GPUs attached to them. But I'll use CPUs. And in this case, I want to have each machine be relatively small for one particular reason, and that's that I want each machine to have, or each Julia process to have access to a decent amount of RAM. And so in this case, just having 16 gigabytes of memory is enough. So you can see the way this is structured is each machine will have 8 gigabytes of memory per vCPU. So since we've structured this with 2 vCPUs per machine, 2 times 8 is 16. And I want one process for each node. I can have this set up for each virtual CPU or for each thread, and that can be useful in some situations. But here I need a lot of memory to process these files in parallel, and so I'll set this up like this with a process per node. Potentially, you could do a heterogeneous cluster using multi-threading as well, if that's advantageous to you. So you could have lots of threads within each machine. In this case, I'm not doing any multi-threading, so 2 vCPUs is plenty for me here. And then I say how many nodes I want. And this is where you can scale out to this. And this entire computation really isn't going to take that long. When I do some, say 24-fold parallelism, it takes about 5 minutes to run, which is a really nice way of doing this. I can set a limit here just in case. If it goes beyond an hour, something's drastically wrong, you need to kill it at that point, but it'll automatically stop once the script has ended. So I'll go in and let's start this job. There are a few other things that I have access to. I can, for example, set a name for this job, so that way I can refer back to it. That's a nice little bit of metadata that you can have in your job. There you can see we have our notification that the job has started successfully. And I can also set up inputs and kind of have a standardized script with kind of tunable knobs, as you will, that you could tune. I've not done that, but you can check out JuliaHub's help section on how you might set up your system like that. So that's starting a job. Now, where'd it go, right? I clicked start, I got a notification, but I don't have any reference to it anymore. Well, it's hidden down in the jobs here. You can see I have a currently running job called webinar. That's the specification. You can stop it directly from Visual Studio Code, or you can go in, look at its logs inside my editor here. It takes just a second to retrieve those logs. Especially once it's just starting up here. I can also, there it comes. So here is my log file that will live stream all of the events that happen in the process of running this. So right now it's still connecting to all of our workers, but once it does so, you'll start seeing these things. I can also go back to my website here. So go back to JuliaHub.com. and go to the jobs that I have running here. So here you can see my running editor, as well as my running, that job that I titled webinar, right, that you saw me submit live. It's been running for 1 minute. I can get some details of it. So you can see it is currently running. Here's the specification that I used when I submitted it and how much time it has left. And as this cluster starts up and brings up, you'll get more and more metrics. So we can kind of see some live metrics as all of these 25 nodes come up, connect to each other, and we'll check back in on this as time goes on. We can kind of watch this here live, but it takes a little bit for all of these processes to connect in and report in both their CPU utilization and their memory utilization. So I'll come back to that and peek in a few minutes once it has a little bit more data as it's doing the processing. In the meantime, let's go and look at an example. Actually, let's do it here in the website. Go back to my job list, and I can go back to a run that I had run earlier, actually early last night as I was preparing myself here. So here you can see this is exactly that same run that I submitted live. It ran for 6 minutes and cost me $1 to run. So it's a nice way. And one of the awesome things about parallelism, especially once you're in the cloud, is that to a limit, right? Depending upon how parallelizable your task is, your cost doesn't change. If I were to run this with one process, it would probably take about 25 times longer and cost me about the same amount of money. And so there's of course some overheads and limits to how parallelizable tasks are. But so the first order, as a rough approximation, it's a very nice trade-off that you have when you're working in the cloud, is that your cost is constant, regardless of the scale. We can go in and look at the details of this previous job here. And one of the really nice things that it has stored for me is it tracks exactly, JuliaHub knows what the project was, what those dependencies were, and allows me to download them. I can look at the code, download that, look at exactly what those things look like. And I also have an output file. So I've serialized some outputs. I'll show you how I structured that in the system there. But all of these things get uploaded and stored in a bundle that is referenceable, right? I have a unique job ID, and I know exactly what happened here. I can go in here. You can see the completed metrics from this previous job, and you can look at for example, the total memory utilization across the entire cluster. We total across these 25 nodes used over 100 gigabytes of RAM as we were doing this processing. It's a great way of looking at what happens. And then also it marks that, hey, we used this data set. It knows that it grabbed accessed the data set. And this is something that we're actively working on to give us better and better views of the provenance of the data that you've run across. So because this is a data set, we know that we accessed it, and we know the version, the ID, the exact thing. And again, this is very helpful for reproducible and validated sorts of environments. Let's go back and kind of check in on this job that I submitted here. So we can go in, let's see if we have the live metrics coming in. Sure enough, here you can see all of these workers are set up, and I can enable all of these here. Let's see if is there a way to, I just click on all of them here. You can see all of them come in. Their memory usage is helpful to keep tabs on, as well as their CPU usage as time goes on. Looks like it's still in the process of reporting all of these things. I can go into the logs where it'll tell me, exactly what is going on. So here you can see I've set up my code to report, when it's starting that PMAP and exactly what files it's working on. So here, I'm getting reports from all of my workers across the cluster as in terms of what file they're working on. In this case, it's the FHV taxi cab sort, which is the for hire vehicles. And you can see, right, we're currently in year 2021, month 10. What's really fun, though, is I can graph this as I go. And there's a live graph that allows me to peek into the state of my cluster as I'm working. So I can see, what, for example, year I'm currently working on, or what car type I'm currently working on. So you can see that all my workers started doing those for hire vehicles and then slowly transitioned over to the high volume for hire vehicles. And now we just got started processing the green taxis. The yellow taxis come last. It goes through this alphabetically is how the files are stored in my data set. So that's why we're working through this. And I can go look at the year that of each as each goes through. So here are all the years of those for hire vehicles. The high volume for hire vehicles are only from 2020. That was a new data set that New York City introduced. Here are those green taxis that were introduced in 2014. And now we're starting on those yellow taxis from 2009 on. This is a great way of looking at it, and kind of depending upon the data that you have, right? This is all just kind of grabbed dynamically from whatever you log. So, right, so any Julia code that you write, you can log exactly what you want and view your results or what's happening here. This is a great way to, for example, keep track of, if you're doing a machine learning sort of task, to keep track of the accuracy as you're training the system, right? That could be what you look at. And you can even plot all sorts of different things here. You can put the type on your y-axis to see, here now we're processing the yellow taxis up through 2013. Up now we have a 2014 reported, and so on and so forth. Lots of fun to be had here. So then I've run this, right? This is still running. It'll take just a few minutes longer to complete, but I can go back to my interactive session here. And I have just kind of a few ways of working with this. So actually, let's go to my jobs. I can go in here and you can see that here's my successful webinar that I ran. I can go in and I can see that there are files attached here. And so here is my output file that I have, and I can click Save button to download that to an interactive session where I can work with it. I can, it saves it as a temporary file. I could save it as a particular, live output as a particular file in my working directory, and this will then be saved in my interactive drive, right? That just kind of as a reference to it, but it's permanently attached to this job. And I'll always know that, what job created what output and what input was a part of it. It's really nice input, code, output tracking sorts of things. So I have this output. What do I do with it now? Well, now is the point where you can kind of play around with it and work to your heart's desire. I had set this up, this output file, as a Julia serialized file. So I'm using the built-in serialization package, which works well if you know exactly the project and manifest that you're using. So that ensures that your data or your versions are consistent. And then you just deserialize it, and this will give me, hopefully, put this in the wrong directory. Hopefully. Output.jls. Oh, here. I'm not in my webinar directory. That's why. So here are those outputs that I have. So these are my results, and you can kind of go in and explore. So, this is the key value pair that I set up. So the first month of the for-hire vehicle, I have stored the total number of trip records here. So there were, 2 million trips using for-hire vehicles. And I've actually stored a Julia object in this. And that's one of the cool things that you can do is I've stored a histogram, which is the kind of the statistics raw way of looking at, the number of bins and such in your data set. I just fit that in my processing script. And so now I have reference to it, and I can set up some very simple functions here to say plot the number of rides or plot the time of day that I want to do with. So you can plot our rides here of my results file using Julia's plotting ecosystem and whatever favorite plots that you have. And this will go through those results and give me a plot of the number of rides per month within each data set. The first time I call plotting takes just a moment. Here we go. We can make this a little bit bigger for you all to see. So here you can see the 4 vehicle types that are in my data set, the yellow taxi cabs and purple. I should probably change my plotting code, but this is where, again, your data scientist hat can go on and move away from looking at data. But here's the yellow taxi cabs decreasing over time as for hire vehicles, that is vehicles like Lyft and Uber and such, start taking over until the 2020 pandemic. Lots of fun things that you can explore in this data set. And there are lots of fun blogs that talk about how to do that. The other kind of cute plot that I put together here is plotting the time of day that you typically would pick up a yellow cab across the entire data set, and that's what that histogram was that I did in parallel. And this is just a heat map from 0 hours since midnight up to 24 hours past midnight. You can see that there's a dead time around 4:30, 5 p.m. that nobody hails yellow cabs, or very few people hail yellow cabs. Here's that 2020 pandemic that will forever be an asterisk in all time series that you ever analyze. And you can kind of see the decrease in yellow taxi cab usage, especially after midnight or so, as Uber and Lyft start becoming more dominant. You can look at the for hire vehicles, for example, here, FHV, and compare and contrast how these things work. Again, there are data issues with this. You have to do all sorts of ETL, but this gives you an idea of how you can look in and see all sorts of fun things in data sets in parallel across. So that's really what I wanted to talk about. We went through, working with large data, uploading those, and hopefully your imagination can see how that can scale not just to 45 gigabytes, but to 45 terabytes and more. And there are extraordinarily capable tools that can interoperate with JuliaHub to enable those uploads. Then we looked at what it looked like to do a parallel compute over such a large data set. And so just to kind of recap, we talked about JuliaHub, how it's structured, how you can work with data on JuliaHub, both as an interactive workspace, right, where you have an interactive persistent drive that is unique just to you and is your scratch space to do all sorts of interactive work. And then datasets, which gives you a very rigorous way of referring to versioned canonical accesses of data that can be shared, not just publicly, but then within enterprise JuliaHub to privately within your teams, is a powerful way of making data available to your team in a secure manner. We talked about how you then single file upload to both sorts of data sources here, both your interactive drive and your data set. And then bulk upload, right? How you get large data into a data set. We talked about how you work with Datasets.jl. That's an open source package with lots of documentation online. And then how you structure your code to do parallel analyses across the ad hoc clusters that JuliaHub can set up. So thank you all for your attention. I'm happy to take Q&A now. And the first question here is a very appropriate one, asking about how AWS works. I've kind of obliquely talked about AWS throughout this webinar. What's the deal with AWS, and how do you do this? How does it connect in? AWS is the platform that backs JuliaHub currently. So JuliaHub itself is hosted on AWS, and thus we use AWS technologies. So for example, when you spin up a interactive node, you're bringing up an EC2 instance. If you're familiar with AWS lingo, that is a machine that AWS can bring up. And similarly, when you store data sets, you're storing them in S3. That's Amazon's kind of simple storage mechanism for arbitrarily large data, and is a very common way of working with lots of data. So that's very AWS specific, and intentionally so, because AWS currently is the only platform that JuliaHub runs on. That will not always be the case. We're actively working on making JuliaHub available both on premises, where you can install an enterprise version of JuliaHub onto your own hardware within your company, and you can contact sales@juliahub.com to learn lots more about how that works. Currently, that only supports the package management sorts of features, but by next year, midpoint of next year, I think we should be able to support compute and data sets and all these fun things. And that's really the beauty here, is that we try to, as much as possible, abstract away from all of the nitty-gritty of the exact cloud service that you're happening to run on, or no cloud service at all, right? If you're on premises, bare hardware that you control and you own, and that can be important in some regulated and high security places. So that is something that we're actively working on, and part of that work then will actually enable JuliaHub to to run on Azure and potentially Google Cloud and other cloud environments. Right now, we are entirely on AWS though, because that is kind of the largest cloud provider, and it's a great place for us to start, but it's not the place that we're ending necessarily. So if you have Azure within your organization and would like to talk to us about how we could potentially interoperate with that, we do, have some interop there already with being able to connect into Azure DevOps for your package servers and such, but JuliaHub will still run on AWS. And if you need to move it to Azure, that's something that we would be happy to talk to you with and let you know as soon as we're ready there. Hopefully that helped answer that question. Any other questions that we have? One final one that I'll talk about, just kind of in terms of, or I guess I'll cover two more here. One is, what kind of data types can you use within JuliaHub as a JuliaHub data set? And really the data sets mechanism itself is completely agnostic to file types. So you can have whatever file type you want to put in there. And depending upon, it's really whatever JuliaHub is, or Julia itself is able to process. So you can find that information directly on juliahub.com just by searching for a particular file type, right? So for example, in this session, I talked about Parquet, and you can find the documentation directly on JuliaHub on how you do that, accessing Parquet. Or, CSV is another ubiquitous file, right? Always end up using CSVs or any other file system, right? So, you might work with Arrow files or other such things. And all of these MAT files, for example, all of these are supported directly within Julia. And then, of course, JuliaHub's datasets don't really care what file types we have. Another question came in as I was answering that one. Thank you for that. That's always great to have good questions, is if you can launch jobs programmatically. And yes, you can. That is, again, going back to JuliaHub. You can go to the JuliaHub client to do so. JuliaHub client has support for, oops, if I spell it correctly, using JuliaHub client. It has support for, say, submitting a new job. You can submit a job, lots of documentation on how that works. Creating jobs, uploading data, using data, all of that is available. You can inspect what jobs are currently running and kind of work with things programmatically. So you don't need to physically click buttons. The last thing that I'll talk about, final question here, will be just kind of in terms of security. When you talk about uploading data, it can be a little scary. How do we ensure your security within this the JuliaHub architecture? And the key answer here is, we want to build on a foundation of trust. We really aim to have a rigorous organization that can pass, muster in terms of encryption controls, regulatory controls, privacy controls, as well as, your application controls. And so JuliaHub itself, once it's in its enterprise environment, can be connected in with your organization's single sign-on to do user management. We stand atop of AWS's data durability guarantees, but on top of that, we have our own standard operating procedures vetted by SOC 2 Type 2 audits and hitting regulatory things that I never thought I would need to worry about, but it is extraordinarily helpful in ensuring that, company-wide, we're following best practices and have audits that can put your regulators and security folks at ease. Thank you so much. I think it looks like the end of the questions here. You're muted, Jay.
Thank you, Matt, and thank you to everyone who joined us today. We will be sending out a follow-up email that will include a link to the video that you can watch this webinar later. And you can always reach out to us if you have any additional questions about JuliaHub. We also have some exciting webinars that are going to come up that we are planning, so I encourage you to watch the space for more. I hope you guys all have a good day. Thank you.
Thank you all for being a part of this.